As you know, the next decade is all about mobility. It's on the go. And the implications of that is that we're dealing with about 10 billion unit devices that are expected to be connected. Well, at the heart of this entire ecosystem, which we very often talk about the software, is actually the underlying hardware. This hardware platform has to ensure that elements such as virtualization can occur in a very optimal manner. And if you look here, one of the things that the hardware has to compensate is actually the virtualization platforms or the software that is supposed to run on these. Another angle to look at is database. One simple example is SAP. You may have already heard about the in-memory technology. So that means that you're going to have to deal with a large footprint of memory. Now, at Samsung, we've been developing memory for quite a long time as the number one player in this industry. We have a history in terms of the innovative solutions that we offer in the industry. And something to keep in mind is when you talk about a large footprint, it means that you also have to increase the density of the component that is in the DIMM modules. And while doing that, you also have to increase the performance. You have to also address the energy efficiency aspect of it. Another thing to also bear in mind is on the disk or the solid state drive or the storage side of it, there's also changes that are happening. What solid state drive brings to the table is also that the latency is significantly reduced compared to the hard drive. And so it's going to help the end user to look at these two entities in the future and see how they can utilize it in an optimal manner. Well, here what you see is that there's a proliferation of applications. Simply look at the number expected in 2012 in terms of how many downloads are going to happen in the mobile space. 50 billion downloads. That's over 600% growth when you compare it to 7 billion in 2009. Why is environmental impact so important for us? Well, did you know that according to McKinsey, data centers are ranked among the fourth pollutants in the industry after the steel, the shipyard, and the airline industry? By 2020, we're talking about a 4x growth in terms of CO2 generated by these equipments. And that means that from 2007, where it was about 80 megatons of CO2, we're talking about 340 megatons of CO2 that have to be addressed. Unless you look again at your hardware, you're going to have a challenge. Governments are also taking a closer look at it. If you look at it from an international perspective, there are regulations that are being talked and discussed and are going to gradually be put in place. In Europe, there's more stringent rules and regulations than in the U.S. But in the U.S. already with Energy Star, there has been talk about recommendations. And once we begin with recommendations, regulations in most instances follow. So what is actually the impact of the memory in the power equation? Looking at, for example, a dual socket scenario with 48 gigabytes of memory, the memory itself, in terms of the power equation, contributes about 26%. That is 6% above the CPU. So now imagine if we're talking in the future about a larger footprint, that the role of the memory in the power equation is going to be critical. So how do we at Samsung address this? Well, one of the things that we have done is always go at the forefront in terms of delivering technology on the latest process node. As we're going to smaller geometries, one of the challenges that we have is ensure that you get higher speed solutions. So the good news is that we're able to drive the speed and the performance up as we're going towards these lower geometry points. Another thing that we're also able to do is increase the density of the components that are manufactured using this process technology. So it means modules 8, 16, 32, and above are going to be the type of modules that you'll be able to get and install in your servers. Our challenge is give you the engine, but ensure that this engine operates at a very low voltage. So driving also the voltage is going to be a key element in terms of reducing the overall power consumption. Today, we talk about 1.35 volts. In the future, we'll be talking about 1.2 and below. So what does that mean from a DIMM perspective? If we take that 48 gigabyte DIMM that we showed earlier on, that was consuming about 102 watts in the DDR2 technology, we're able to deliver to you a 14-watt solution for 48 gigabytes of memory. If you put that in the scale of a gigabyte, watts per gigabyte, you're going from 2 watts per gigabyte down to 0.29 watts per gigabyte. That's about 86% saving in terms of power consumption. Now for you, obviously, you're wondering, okay, what does that mean for the server? Well, the server is going to benefit from the power reduction that you're having in the DIMMs. And so what we see, based on some analysis and tests that we have done, is that the server is going to be able to save about 44% of power saving. And this is what we call basically the Samsung Green Memory technology, the combination of giving you ultimate performance at the lowest power point.